In this video we're going to look at trigonometric functions, and we're going to look at sine wave, cos wave and tan wave. Okay, so it's just a graph of these functions. If you look at this, this is sine wave. Okay, so it's sine of x. And if you notice, let's just say we start at the origin here. Sine of x, actually just before I start, you notice here I have pi over 2, pi, 3 pi over 2. But I've translated it to degrees, so we've 90 degrees here, 180, 270, 360, 450, and so on. And if you look back this way, we've minus 90, minus 180, minus 270, and so on. But let's say we start here at the origin. Right, sine wave, if it's just sine of x, okay, so just this, if we have sine of x, it starts here at the origin, it goes up to 1, so it hits 1 at 90 degrees, it comes back down, it hits 0 at 180 degrees, it goes down then to minus 1 at 270 degrees, and back up to 0 at 360 degrees. So sine wave, the sine of x, goes between 0 and 360. We call that its period, because after that it repeats again. There it is, and it repeats again, and so on. And likewise back this way, it'll go to here, and then it'll repeat again, and so on. Okay? Also, its range, so the range of sine of x goes between 1 and minus 1, because it goes up and down between 1 and minus 1 the whole time. If you look here, it starts at 0, goes up to 1, minus 1, 1, minus 1, 1, minus 1. So it alternates between 1 and minus 1, depending on where we are in the graph. Okay, this one is cos of x. Cos of x, starting at the origin, starts at 1. At 90 degrees then, or pi over 2, it's down to 0. At 180 degrees, it's minus 1. At 270 degrees, it's at 0. And then back up to 1 again. Okay, so there's its period from here to here. And likewise then, it goes again, and again, and back the way. Okay, so that's cos of x. Again, its period between 0 and 2 pi, or between 0 and 360 degrees. Its range between 1 and minus 1. That's cos of x. Okay, tan of x then. Tan of x is a bit different. Okay, tan of x at the origin is 0, but look what happens here. It goes up, 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 and down, 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 and then it starts at pi, which is 180, and it goes up, and it goes down, and 2 pi, which is 360 degrees, goes up and it goes down. And if you notice here, see this 90 degrees, we call that an asymptote, because as the tan line, okay, so as this line keeps going up and 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 up, and this keeps going down, 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 it will approach this line here, but it will actually never hit it. It'll get closer and closer and closer to it, but it'll never hit it. So we call that an asymptote. So there's an asymptote at 90 degrees, and there's also an asymptote at 270 degrees, etc. Okay, and that's tan of x. Okay, now we look at something like sine 2x. We looked already at sine x, and sine x we saw started here, at at 90 degrees was here, 180 degrees was here, and then here, and then here. Okay, its range was between 1 and -1. Its period was 0 and 360 degrees. Okay, so from where it started to where it went back to itself, it took 360 degrees to do that. That was sine of x. Notice though, with sine 2x, the fact I put in a 2 here, that means I will divide the period by 2. So watch. The period now starts here, but it finishes at here. That's half what the period was. Okay, so now we can say the period of sine 2x is 180 degrees. Sine x was 360, sine 2x 180. Just divide the period by 2. If I said the sine of 3x, well then it would be 360 degrees divided by 3, which would give me 120 degrees. So that means at 120 degrees, which would be around, let's say here, it would go up, down, and up again. Okay, so it would repeat itself every 120 degrees. Notice though, the range stays the same. Okay, it's between 1 and -1. Okay. In this one then, cos of 2x, exact same again. Its range is between 1 and -1. However, its period, it starts here, it goes down and up 360 degrees divided by 2, so its period is 180 degrees. Notice then, just like the other one, the next 180 degrees, it goes again, and the next 180 degrees goes again. And likewise, back the way. So 180 degrees repeats itself again, another 180 degrees repeats itself again. If that's in cos 2x. If it was cos x, it would repeat itself every 360 degrees. If it was cos 3x, well then 360 divided by 3 is 120. So this would repeat itself every 120 degrees. Okay, this is the graph of tan 2x. Notice in tan x, the asymptote was at every 90 degrees. Okay, so there's an asymptote here, here, at every Now let's look at this one. 2 sine 2x. So this 2 ensures the range is between 2 and minus 2. This 2 ensures the period has halved. Okay, so if I was to draw this, I would be going up to 2, down to minus 2, and this 2 here then, this one, ensures that the period is halved. Remember, the period for sine is 360 degrees, so if we halve that, 180. So it starts here, goes up to 2, down to minus 2, back up to 0. And all that is done within this 180 degrees, and then it repeats itself again. So up, down, back, all done in 180 degrees. And then the last one, the graph of, let's say, 3 cos 2x, where we're looking at cos. Notice it's the 3 here, ensures the range goes between 3 and minus 3. And this 2 here ensures that the period, which was 360 for cos x, now is divided by 2, so it's 180. So we start here at 3, all the way down to minus 3, all the way back up, and that there, that period is 180 degrees. And then it starts again and repeats itself again between 3 and minus 3. Okay, so that's it, guys. That's the graphs of sine, cos and tan waves. Okay, thank you.